Very. How exciting. Alright, I think we're live again. Who can tell? I guess I'll paste it in again. Alright, so if you weren't here 10 seconds ago, it turns out that the most recent Microsoft Windows update made it so that my mic wasn't showing up in OBS. It was working everywhere else, but for some reason OBS decided that default no longer meant default, presumably because Windows is responding to default with things like my internal video card's microphone, which doesn't actually exist, but obviously the video card people don't know that because they keep enabling it. So, I went ahead and created some very generic animations for this lower character. And we're going to go ahead and create a character controller today. The upper character is the current character setup. It doesn't work anymore. There are a lot of reasons, the biggest one being that Unity decided it was never going to import animations from Blender ever again. Don't know why. So now I have to whip up an entirely different pipeline, and I figured I might as well whip up an entirely different character while I was at it. So that's what we've got this character, Diver B. And I've already built all of the animations, the base animations that we're going to need off screen. They're not really very good, but the point is that they will work. Now this is the one that's bugged, and it's bugged because those tentacles are supposed to be going up and down, not left and right. The problem is that they're going world axis X and world axis Y when they actually need to be going local axis X and local axis Y. I'll show you why that's incredibly important by simply rotating the character 90 degrees. No, that seems like they're still local axis X, doesn't it? They're not rippling. Maybe I'm wrong. They must be being applied. Okay, so it's not world axis. It's that they're being applied after the skeletal change. I wanted them to be applied before the skeletal change. I don't know. I guess there's probably nothing I can do about that because the skeletal change isn't really part of the shader. I guess in order for me to do it this way, I'm going to need to have a separate y-axis sine wave. All right, well, let's go ahead and build that before we go any further because I obviously need both. Oh, let me make sure I've got some stuff up there. Alan stopped in to say heyo. Heyo. Depending on how fast he was, he may have chimed in before I actually started streaming, thanks to my microphone issues. So here's the Diver Tentacles shader. Just pop it up off screen. There it is on screen. And basically, this is not as complicated as it looks. It's got a couple of things that are... it's got two basic elements to it. One is the glow, because basically this top glow here is actually an energy meter. See? So that's half of this nonsense. And the other half is the actual wobbling bit. So the wobbling bit is done down here. As you can see, it's got this. And basically all we need to do is make it so that instead of being X, it's either X or Y or both, depending on our setup. So for starters, what I think I'm going to do is drag some of this stuff out a little bit further and put it into its own block so I don't have to keep thinking about what the heck it actually is. So I believe that that's the glow. There we are. And then with that off on its own side, we can then take this move it back and call it wobble scale. And then here, what we can do is we can put in two lerps. Lerp. And another lerp. Lerp. And we're going to need another property. Here's our property. Property. We're going to need x-axis wobble %. We'll just call it X wobble. Drop that in there, and then here. And then we're going to have another one named Y wobble. It looks like my neighbors have started up their weekly Calypso party. Work is basically done for the year, so I don't begrudge them that, but if you hear festive music in the background, that's why. There we are. So now all we've done is we've made it so that it can go either X or Y as we prefer, or both as we prefer. So now that we've got that going, I think I meant Z. I meant Z. Y is not the right one. So if I were to show you with the Y, you can see how it's kind of like legs going pachoo. Yay! Obviously, I meant it to go up and down, not forward and backwards. I just forgot which of these axes was which because I've been doing too much Blender stuff recently. Z. That's more like it. But here you can see that we've got a problem where the left and the right are going in opposite directions. And that's because of the way that I set this up. And I actually don't want that for the vertical axis. So here you can see how we've got this if statement. We actually need to pull these out here. Yeah, so... Sorry, I'm just thinking about how this gets set up. And it's this multiply that's actually putting out the number we need. And then these values need to be set up depending on what we're trying to do. So this goes, straight into this portion. And then this simply determines the x-axis wobble so that they come together rather than moving left and right at the same time and causing slosh. So that should be all we need to do. Super Donut stopped in to say hello. Hello, Super Donut. So now you can see that they're synced up instead of being one up and one down. So if we were going to look at that, this is like the sprint animation where we're trying to go super fast. The actual values involved are not quite set up yet, but that's going to be coming in real soon here. So what we can do is we can turn off the X wobble because we don't want it. And I just want to make sure that this is not terrible, and it has a problem. The tentacles are cutting into my butt. So I think we better open that up and re-export it just with tentacles that aren't cutting into my butt. That's not the genre we're working in. So if we pop that up, swim fast. You can see the issue here is that these tentacles in the game engine go up and down quite a bit, whereas here in our editor, they are in a specific position. We're going to go ahead and just completely reset these, because there's something screwy about how they're set up. So just go over here and press that. So what we're going to need to do is rotate these on their local y-axis to create a flat plane, like so. And that way when we go up and down, that will really make sense. Then what we're going to do is make sure these are not twisted at all yet. Okay. Then what we're going to do is rotate this until it is straight. Give us direct action. But you can see that we're much too close to the body. So all we really have to do is to make sure that these are a little bit further from the body. We'll go ahead and separate them out. Go ahead and do both of these here. Rotate Z15. No, sorry, rotate Z15. Too much. Rotate Z10. Rotate Z12. The problem is that I need to do it again on the other side, which is why I need a number. There we are. And that's a lot less likely to cause us some issues, but there's still going to be some butt clipping. So let's go ahead and try that again. There, now there won't be any butt clipping. All right, and now we're just going to insert the whole character and then copy. Can I get a handle here? Copy this, paste it, save it, Export it. Come on. Export. Go over here and into this. Don't export the cameras or the lamps. I wish I could save a permanent default here. It won't let me. So export. That'll take about 10 seconds because it's got to bake all of these stupid quote-unquote animations. None of them actually have any moving parts except for the flip over ones. They're really just poses. Super Donut says, "What do I do when I want music in my games? Do I find some or make my own?" I don't have any musical talent. When I was a kid, I thought I did. Didn't really work out. All the music I use, I bought on the Asset Store. My favorite songs are from. I'm blanking on his name. I can look it up if it's necessary, but he costs money. They're not free. I recommend that if you're not spending money on anything, you can just go ahead and get some of the free music, the CC0 music or the attribution music that you can find out on the internet. Just make sure to, when you save the file into your game, make sure that you save it with the name of the author as part of the name of the song, because otherwise you'll forget who gave it to you. And that's not something you want to do. Even if it's CC0, you want to keep track of that. So he wants to know roughly how much it would be to buy music from the Asset Store. So for a genre pack, I think it's about $20. And that's like 30 or 40 songs. Or maybe not. Maybe it's more like a dozen songs with some variants to let you mix them up. If we were going to head on over into the shop, I don't actually have a shop window open because I hate the shop so much. It's just the worst. And we can go over into the old shop. We can go into music. And there's a bunch of things here. So I have some songs from Infenzia. His stuff ain't bad. It's not my absolute favorite, but it's not bad. I'm not sure about Evil Mind. I tried their stuff about 5 years ago. It was a little bit primitive at the time. But my favorite isn't showing up here. Is he not popular enough, or did he remove all of his stuff? I wonder. Interesting. I don't, these are like not enough to even be, interesting that he's not showing up at all. I would have thought that, maybe he's no longer selling, in which case, just get whatever you want. Infenzia is probably my recommendation if you can't find whatever I'm using. Maybe he just changed his name and one of these is his name and I just don't happen to recognize it. But you can see that they come in a wide variety. We've got some that are like $5, $6, and some that are like $45, $50. Generally speaking, the more money you pay, the more songs you get. It doesn't reflect the quality of the songs. It's very rare for the quality of the songs and the price of the songs to have any correlation in the Unity Asset Store. So try and get yourself some sound bites. For example, I don't know anything about this Audio Alchemist guy, so what I would do is I would see whether or not I could get myself some sound bites. And look, you've got a whole bunch of OGs here. And you should be able to get some kind of, there's a SoundCloud link. So you should be able to figure out what he sounds like. Make sure that you like what you hear before you buy it, because cheap or expensive is irrelevant when it comes to music in the Asset Store. It's all about whether or not you can find someone. And if you buy it on the Asset Store, you can use it in Unity projects. Usually it's pretty freeform about that. You don't need to worry about having multiple seats or using it in multiple games. If you buy a Unity Store license, you can use it in your Unity games. But you won't be able to use it in, say, an Unreal game or a Godot game. If you wanted to do that, I would recommend contacting the musician. Generally speaking, if you paid them, they're happy to let you keep using their music. I'd also be careful. A lot of this music is music that will get copyright strikes on YouTube. And so you want to be careful to maybe test and see whether or not the music is going to get copyright strikes, because it's best if you don't have any copyright bots following your music. If there are copyright bots chasing your music down, then anyone who's doing Let's Plays is going to get monetized by a stranger and screwed over, and that's going to piss them off, and they're not going to want to play your games. So CC0 music that has no YouTube bot problems is probably the easiest place to start. So that's probably where I would start. Well, we'll try it. I can always change the animations later. So anyway, what we're going to do is we're going to take this diver B animations, drop them into the player object, hide the current diver animations, and replace them with our new buddy, Diver B. Diver B is going to have a lot of fun trying to get things done, but one of the things Diver B is going to have to do is get things plugged in. So Diver B has to have the right animator, the right values, but also things like hand tracking and head tracking. So what we're going to want to have is some kind of function that can add those things to our diver without needing to continually try and dig down into the armature and figure it out. So in order to do that, what we're going to do is we are going to come up with a diver controller subclass, an object we can stick on this that'll allow us to just create the diver in a heartbeat. So here we've got the player controller script, and we're just going to expand that to include a diver population script. Here you can see the diver animations. If we drop the new one in there, you can see that we have a different value, but the problem is that it's not passing in the right arguments anymore, which is fine. The player controller is super primitive. I think it's like 200 lines of code. Very, very basic. So it doesn't really matter if we tear it apart and fix it up. It's pretty much irrelevant. Exciting. Yeah. Oh, wow. Really? Okay, so it's a little bit simpler than I remember. The camera code must be handled somewhere else. It's no big deal. So the basic issue is that all this does is move us around. And then it does this. Oh, it's in the I see. I've just got another object happening here. So I've got to go find it. Unfortunately, the one thing I've never managed to figure out with Writer is how to go find shit. Why are you getting the action ready? Just go. Do I have to find usages? I don't want to find usages. I just want to... Okay, so Writer is being a pain in the ass here. I just need to open up that file. I'm not sure why Writer... I'm sure Writer has the ability to open that file, and I just don't know the way to do it. Yeah, okay, F12. I'll try and remember that. Mifa says F12. Oh, so he had it at the same time I had it. Yep. So there we go. Here, this is the more complicated stuff. The big difference between the diver controller and the player controller is that the player controller obviously allows the player to control, whereas the diver controller is agnostic and can be controlled by anything. There is an NPC diver controller whose only purpose is to have it chase you around, that character chase you around, works on the exact same code. So you can see that this is a little bit more complex. It's not really complex, it's only 73 lines, but it's definitely more complex than it was. So what we've basically got going here is some tilt calculations and some control values, and we rely heavily on rigid bodies and colliders to keep us from falling through anything. So the tilt check, I'm just checking to see what sort of changes we're going to have to make. And basically, we're just going to have to change the names of these. So if we take a look at the controller in question, boom, speed, turn, tilt, and inverted. So you can see we don't have a forward anymore. It's now called speed. I don't know why I called it speed. I should just call it forward. Forward. Now it should be more compatible. Turn is the same. Down here you can see we've got this called dive when it actually needs to be called tilt. But here's the thing, I think this is probably inverted. That's no big deal. We can always just invert it later if we need to. And that should make it compatible with the new animator. Of course, the buddy diver is no longer going to work because they're using the old one. So we're going to go ahead and hide. What's going on here? That was weird and slow. My computer is chewing on something. I'm presuming it's trying to figure out where to find the references or whatever when I first tried to do that and then clicked off of it. So in theory, yeah, so you can see how putting aside the way the tentacles are waving, this is perfectly fine. This is more or less how it's supposed to look. There are some problems, but by and large, it's reacting correctly. So what we've got to do is fix all the problems. I think one of the problems is that for some reason I've tilted it by 15 degrees. I'm not sure why I did that, but it was certainly making things look weird. So now what we're going to want to do is have the material get overridden with the diver's various values. Oh, that looks great. Okay, so the material has so Super Donut says, when you helped me earlier, you said that when the player stops, he should have red lights indicating he's going to die. But I'm thinking a hand following the player that gets closer if he stops. Sure, whatever you think is best. The whole point is just that you don't want to kill the player in one frame, because it really, you need at least half a second to really make that tension pop. So I would recommend that you come up with some way to come up with a half-second delay so that the player will die slowly. It's always more fun. So we got a couple of things that we're trying to do here, but the biggest one is we are going to be using a set of overrides for a lot of our materials. We've got a couple of mesh renderers that are going to have materials attached to them, and those materials are going to be overridden. But the problem is that this bad boy has two materials, metal and tank. So we're not going to be able to use that one. We're only going to want the ones that have one material. We'll have to think about exactly what we want to do later, but basically we're going to have a list of skinned mesh renderers, and we're going to assume that it's always going to be the first material that we want to override. So player materials. So that's going to be a list of materials. The only problem now, I don't think it'll barf if I give it values that don't exist in certain materials. We'll find out, because the body and the tank and all that stuff have the same energy override, but they don't have the wobbly bits override. So I might have to have like a separate tentacle skinned mesh renderer. But either way, we can just go ahead and plug that in here. So we're going to have a protected material property block. There we go. And we'll go ahead and set that up Well, my fingers don't work. I haven't eaten very much today. So maybe my brain is not operating on full right now. So what we want to do is we want to set the material property block up to have the correct values. And the correct values, there are going to be a couple. Public float energy equals 1. Public float, and these are the ones that are going to be a little bit less easy to define. So we're going to have a what do we call it? Wobble axis? You know what? I shouldn't be doing it here, should I? Let's make a new class to do this. I guess we don't have scripts specifically for the diver built yet. We'll go ahead and create a new divers. I guess they're a category of life, really, but we'll go ahead and go in here and create a new one. C# script. And we'll call this diver material handler. And we'll go ahead and open that up. But we're also going to want to drop it here on the player. Shtaboom. Can we put it in? Just drop it anywhere? There we are. So basically, the skin mesh render, just delete that, put it in here. And then down here, it's giving us a barf on this material property block. Because apparently we're not allowed to define one outside of run mode. So we're going to go ahead and just not define it for now. Here in start, we'll go ahead and define it. I think that should be in awake so that we don't have any problems if things go in other orders. Should all work. And basically what we're going to want to do is we have two options. We can either have the player controller constantly tell the diver material handler something or vice versa. I think that we're going to want to rename this from diver material handler to diver status handler. Let's go ahead and refactor this. Rename diver status handler. There we are. Even renamed the CS file for me. Nice. So now that we've got this set up as a diver status handler, what we can do is have it handle a lot of the more complicated stuff. So one of those things is going to be energy. So let's go up here, grab that energy. I recently watched that Rock and Roll Nightmare, and so I've got the energy song stuck in my head. Don't see any energy here. Did I not actually add it? Did I just think I added it? I must have just thought I added it. Sorry, I'm about to sneeze. So what we're going to do is down here in material property blocks, I guess we're going to do it in update. So we'll make this a skin to mesh renderer. And all we're going to do is say smr.set material property block. Is a skin mesh renderer not the thing we need? Is it a mesh renderer, or is it just a mesh on them? I thought the skin mesh renderer contained the mesh. We should be able to set the skin mesh renderer material property block. Yeah, there we are. I guess there's no reason to do it. Deleted. Boom. Shtoom. We just do a for each skinned mesh renderer SMR in player materials. Joof. And then above that, we set up MPB. MPB set float energy and then energy. So if I take a look at what sort of values we're actually using, I don't think it's actually called energy. I think it's called underscore energy. So yeah, underscore energy. There we are. I don't know why it's underlined in yellow. String-based, it's inefficient. I don't care. And then we've got a couple of others. We've got mpb.setFloat. XWobble. And we'll just go ahead and call that XWobble here too. This will be YWobble, which we'll call YWobble. Up here we'll create that, so public float XWobble. Sorry, I'm thinking about how to do this. I think a bool is better. And then we just do public float XWobble get return horrors wobble question mark 1 0, and then we repeat the process for YWobble. All right, so now what we've got is the X and the Y wobble. What we don't have is a setup for telling the diver status handler what sort of parameters we're looking at. How fast are we moving? How can you tell? Well, basically what we've got is this diver controller that will try and remember what the values are. And when it is doing this, you can see how it sets last forward to forward, last turn to turn, last dive to dive. If we grab those values, we're going to be able to figure out exactly what we would like. So over here in the diver status helper, we're going to go ahead and create a public diver controller. Actually, it's not public, protected. Let's go ahead and just arrange these a little bit. That's just going to be a value. I don't want to do that. Protected diver controller DC, and then what we're going to do here is we're going to have a get if DC equals null, then DC equals get component diver controller. Return DC. A simple little lookup so that we don't have to keep looking it up every frame. And down here, what we're going to want to do is we're going to say horizontal wobble equals DC dot last. Are those not global? They're protected. I want to go ahead and make them protected, and what we'll do is we'll create a fetcher. There we are. So that's going to give us a forward value, and we're going to go ahead and see whether or not it's less than 0.6f. Basically, it's only going to get vertical if we're in a sprint mode, and we're only going to be in a sprint mode if we are holding shift. So now we've got that set up. We're also going to want to make sure that we have the DC forward set up to change the amplitude and frequency. So for those, we're going to need to have some easier values to set that up. So public animation curve. Sorry, it's there's like Caribbean music in the background here. It's very hard to focus. So this is going to be wobble amplitude. And this is going to be wobble frequency. And we'll go ahead and make those linear. We should be able to say this. And we can just say time start 0, 0, 1, 1. And we can just do the same. Except for this one is not going to be anywhere near 0 and 1. It's more like 15 and 45. So from there, what we can do is we can simply set the MPB up properly. Like that. And then for frequency, do the same thing. Like so. That should be all we need in order to make this work. The only issue here is that the actual animator isn't set up properly just yet. Alan Wyvern says, I really like this function variable names in the call, very helpful. Yeah, that's something I'm a little torn on just because I'm not used to it yet. So Writer is actually a very high quality product, and it really understands how C# works. Even within Unity, it's got a Unity specific understanding of how things work. So in addition to stuff like helpful hints like this, it'll do things like, hey, this is going to be slow in Unity, but I don't care if it's going to be slow in Unity. So what we're going to do is hit play. I forgot to set any of them up, though. Hold on. I got to actually tell it what materials we're looking for here. So we're going to drop in the diver tentacles, and that should be it for now. So you can see that I've got the amplitude and the frequency backwards. Maybe. But you can see how it starts off horizontal and then it turns vertical. That's kind of the point. So the thing that we're going to have to implement now is there's one little sticky point that I'm not so sure I like. The player controller handles whether or not you're accelerating and how fast you're accelerating. But it doesn't handle how much energy you have. The diver status handler tells you how much energy you have. I'm thinking that what I'll do is I'll have the player controller have a reference to the diver status handler, and if it can find a diver status handler, it will adjust the energy. That's all I can think of. I could combine the two into one class, but that feels like that class would get really fat, you know? Don't really feel like that. So anyway, I think that this wobble amplitude might just be way too high. So let's bring it down to like this. The wobble amplitude should be how aggressively side to side it wobbles. Yeah, so you can see how it's now much smaller. But the frequency is really high, much higher than I expected. So we're just going to bring down this wobble frequency. Oh, you know what? It's speed that I wanted to change, not frequency. That's why. Hold on. Anim speed. Yeah, okay. My bad. Frequency is the number of waves along the meter length, whereas speed is how fast they actually wobble. Alan Wyvern says amazing, but I can't actually tell what he's saying amazing about because I don't pay enough attention. There we go. It's a little bit more like what I'm looking to do. Obviously, it needs some work. I think the frequency is probably... The anim speed's too high and the frequency is probably a little bit iffy. But one of the issues is that we haven't actually plugged it in properly yet. So there's still plenty of work left to do. Let's go ahead and change this. Edit key, bring that down to 30. I don't know why it was at 45. That's probably why. 45 is much too high. But what we need to do is make it so that when the player controller script... did I close writer? I'm not very smart. Let's go ahead and close this down. We don't need it. And then we will wait another 15 or 20 minutes for writer to open here. Take a sip. There we are. So this is very, very basic, right? And the question is whether or not we want the player controller specifically to have an energy meter. And I think we do. I think we never want the NPCs to... No, wait. I'm lying. I think the diver controller might have to handle the energy. I don't want it to, but I can't think of a... No. So the diver controller has to be able to tell us how much energy it's burning and also understand whether or not it has enough energy to keep going at a high speed. So basically, we've got this forward, and we've got this blah, 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 all this jazz. So here, when we do this lerping, forward, 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 what we actually need to do is the forward should range between 0 and 1. But the key here is that we're never going to pass it in a 1 with that sort of basic value. So I'm going to divide this by 2. And then back here in diver controller, we're going to divide the reverse by 2. Actually, we don't have to divide the reverse at all, do we? We're just going to leave it. And that's going to be a value between negative 0.5 and 0.5. So when we do that, we're going to end up quite a bit slower than we were. But what we actually need to do is have a speed that is... I'm trying to click out the end of the line. Thank you. Animation curve. Forward speed equals animation curve dot linear. That's going to be 0. I guess it's a 3 and then a 1 and then, I don't know, a 10. And then we're going to delete this. Now forward speed comes up a couple of times, like here. What we're going to need to do is evaluate that. No, well. So that ought to give us a value between 0 and 0.5 along the range that we've specified for our speed. But what we need to add in now is the ability for us to go faster than that by holding shift. So let's go over here and add in a shift-based, or just verify that there is a shift-based input setup. Is it in project settings? Yeah, here it is. Horizontal, vertical, dive, jump, so Fire 3 is currently set up to be what we need. Let's just rename it. We don't need Fire 3. Let's call it Sprint. We got a positive button, and it's also mouse 2. I don't think we want mouse 2. Is mouse 2 the middle button or the right button? I don't think we want that as an alt. Let's go ahead and leave it as an alt for now. We'll bring it back later. Mouse 2 is right click. All right, so we'll leave it as right clicked for now. We can always change it later. So just save that and then close it. I don't think we needed to save it. So here we've got a couple of garbage errors. So I'm not sure what we're doing with this. Seems a little complicated for no particular reason, so we're going to go ahead and copy it out and just set it as forward. The only issue here is that there won't be any lerping, but we should be lerping in the axis itself because we're not getting the raw axis, but we are getting the raw shift axis. No, we're not. We're not going to get it. We're going to go ahead and do I want to multiply them together? Yeah, so we're going to go ahead and say float forward equals 0, and then we're going to say if input.getAxis shift sprint, I call it sprint, is greater than 0, then what we're going to want to do is say that forward equals input.getAxis vertical times input.getAxis sprint. Not forward, forward. And then we'll say else forward. Hello, what did you deselect everything all of a sudden? There we are. So basically what's happening here is we're going to rely on the, wow, I'm not yet used to this. It's being excessively helpful and screwing me up. Basically, we're going to be relying on the nature of the inputs to automatically... Alan Wyvern says, not get button. No, because what I want to do is specifically, I'll show you. Specifically, I want to use this gravity here. Yeah, I guess 3 is best. So that when you press shift, you accelerate towards your full speed rather than snapping towards your full speed. I don't have any speed lerping going on in the actual interior, so the raw values that are coming in off of the inputs are how fast it's trying to make you go. So with that in mind, we'll be using the built-in input lags. Let's go ahead and try it. So first, if I hold forward, it should be, yeah, like that. That's not bad. We're going not fast at all. It looks like there might be something wrong with how we're interpreting our speed. But if I hold shift, you can see how I switch to a sprint. That's what we want. There are some issues here. For example, we're not moving at all. And that's what we're going to fix now. So we're passing these correct values in, and we're showing them up correctly, but then what we're doing is we're screwing it up somewhere else. So here what we've got as a delta is transform.forward times forward speed evaluate forward. That should be correct. My guess is that our forward speed isn't properly set up. It's not. That's the problem. No biggie. We'll set it up. So edit key, we'll make this 3, and we'll make this 10. But in order to make this feel right, what we're actually going to do is make this fairly sharp with a plateau in the middle. There we are. So Alan says, why did you set it to the input rather than just the directional vector magnitude? I'm not sure what he means. You could get a more granular animation, right? I'm not really sure what you're talking about. You're probably talking about an animation setup in the animation controller. I'm using a multi-axis animation setup in the controller as well. But until I know a little bit more about what you mean, it's going to be a hard thing for me to explain. You see that snap right there? I don't like that snap. I want that to go away. So I'm not sure why it's doing that, but this is a good time for us to start debugging the animation pipeline because we haven't really done any of that, and it's very, very primitive. Oh, Alan says because I should set it equal to the current speed of the character. Yeah, well the problem is we're underwater. So we actually want to have a much more aggressive animation when we're not moving because we have to push against all that water. And I might add that in later. I might make it like the difference between the current speed and our target speed is the actual animation, with some drag built in. But for now, I'm okay with just doing it like this. But from the fact that you're underwater, you need to be pushing real hard before you reach speed. So that's kind of the idea. We've got a speed delay because we're using a rigid body. And we're adding, I believe, forces to it. Maybe we're setting the actual velocity. No, we're adding to the velocity here. So we're kind of lerping towards the target velocity, which means that we get the animation right away, and then we reach the target velocity. And that's a good way to sort of get that sense that you're pushing to reach that speed. It's not really how I would do it, but it is not too terrible, I guess. So here in the turn tree, this is our current turn tree, and we got a couple of problems with this turn tree. So one of the problems that we've got with this turn tree is the way that it does its main swim elements here. It determines whether it is going to be doing these. Okay, so I have to pop up the inspector. There it is. Two of the positions are too close to each other. Well, maybe that's why we were getting that weird snap. But there shouldn't be two positions that are too close to each other. Do you see any positions that are too close to each other? So it works now that I've changed it away and then back again. Basically, what we're doing is we've got a slow animation right there in the middle. This can be negative 0.5. There we are. But the issue here is that when we're doing this animation, if we've got a 0.5 in this value, we don't get any of these other elements because they're so far off to the side. So what we do is we change them to 0.5s, and that'll give us a much tighter blend. And in theory, that'll give us a better set of animations. But we can also change it to have a different set of priorities, which we'll talk about later. Alan Wyvern says that he didn't actually get that the tentacle things were propulsion. Yeah. Basically, if I actually have to animate how the diver moves, how a realistic diver moves underwater, it looks really dumb because it's just frog kicks, and frog kicks look awful. So if I do it something like this, then it feels like you're cool. And it also makes you feel a little bit less human, which is good because you're not human. You're a robot. So we got a couple of things left to do. One, I think that our inputs are not slow enough. So we're going to go in and slow them down. And two, I want to change this so that the energy actually goes down. To do that, I will need to draw energy out of the status handler, this energy right here, and restore it in and that sort of jazz. So over here in the status handler, what we're going to want to do is restore the energy if we're low. So in our update, there we are. If energy, well, let's just do energy equals mathf.moveTowards, and then we will go ahead and move towards the current value, energy towards 1 with a time.delta time. And we can go ahead and change that. So just public float recharge speed equals 1. And we'll just go ahead and say times recharge speed. There we go. That'll allow us to recharge slower or faster, but we still need to be able to draw energy out from it. And that means that we're going to need the diver controller to have an optional diver status handler where it can get energy from. So we're going to go ahead and add that now. Like that. And we'll go ahead and put in a tooltip to remind us what's going on. If empty, character has infinite energy. There we are. So down here, Do I want to put it there? I don't know where I want to put it, but I guess I can change it later. Let's put it in the player controller. And basically here in update, if we're sprinting, what we've got to do is determine whether or not we have enough energy to actually sprint. So, so if sprint is greater than 0, if diver status handler, no, it's optional status handler. If optional status handler, then we want to say whether or not we've got any energy. If energy is greater than 0, sorry, optional status handler.energy, then we want to subtract it, optional status handler dot burn. So what we're going to want to do is create a function called burn for that purpose. Otherwise, we'll want to set sprint to 0. And then here we're going to say if sprint is greater than 0, then forward times equals sprint. Otherwise, forward divided by equals 2. It's not very complicated. It's just that I had to do it all out of order. Now we're going to need to have a burn command. Now the reason we're putting burn over here is so that we can change how fast things burn without having to worry about, which class we have to look shit up in. Let's just go ahead and leave it empty. For now, we're just going to minus, so minus equals time.delta time. Let's go ahead and divide that by 3. Give us 3 seconds to sprint. Later on, we'll go ahead and make that more interesting. The only issue here is that energy gets restored. So what we actually need to do is put in like a thing where it doesn't get restored if we recently did stuff. So protected energy burned equals 0. Energy burned timer equals 0. And here we can say if energy burned timer is greater than 0, then I forgot to actually tell it what it was. Float. There we go. That way we can down here say energy burned timer equals 0.5. Let's go ahead and try it out. Let's see what's up. Shrink that, don't close it. And then over here in the optional status handler, we'll just drop in our status handler and then we'll hit play. So this is us cruising along at, this is way too fast. We'll be lowering the speed rather dramatically shortly. But if we hold shift, you can see our energy drains and then we go back down and then we sit here and go flickety, flickety, flickety. So that is the idea. It needs some work. It's a little hard to see. One of the things we've got to do is switch the visual on those tentacles. So we're going to go over here into animations, this guy. Grab these tentacles. Exit, there we are. Grab these tentacles. We'll switch over into UV editing mode. I don't know why they put this on the left. It never really made any sense to me. But basically, oh, I got the wrong object. Here we are. This is how it looks, right? All we really need to do is scale Y -1 it, and it'll work fine. But we do have to re-export. Now it should be the same, except for the glow will go towards the the pack rather than towards our feet. Yeah. And you can see how that should be a little bit easier for us to detect. Now that said, there's also going to be plenty of glow in other locations. It's not going to just be there. We still got a lot of snapping here on the animations. And you can see how there's a lot of weird vibration happening. I think what's happening is the animation speed is changing. Yeah, that's exactly what's happening. So because the animation speed is, you multiply the amount of time passed from level load by animation speed, and the result is the current sine wave location. If we change the animation speed, the further we get from launching the level, the more of a jump there will be when we change the animation speed. So because of that, what we actually want to do with the animation speed is not make it a smooth line at all. We need to make it a bump, a plateau. So to do that, we just add a couple more points. So whoops, that wasn't what I wanted to do. This might be better if it wasn't an animation curve. Let's go ahead and just fix this so that it's not, because it's never going to work as an animation curve. There's no reason to leave it as an animation curve. That's wrong. You could have avoided this by just using a screw. So I actually originally planned to use a screw, a turbine attached to your hips, but I couldn't make it look fun. Whereas I want to play up the fact that you're not a human and you got some weird stuff going on. So, you know, I think that this is the better option. I'm not sure, though. Yeah. So basically, the real thing we're going to be doing is changing the amplitude. The wobble speeds should just be like a very basic snap. So the value is going to be dc.forward less than 0.6 f, slow wobble speed, or fast wobble speed. There we go. That should do fine. We don't need to have the sliding wobble scale. That's going to make our animations look super choppy. Alan thinks that what I'm doing looks fine. It's good to hear. There we are. So now you can see that we're no longer getting the super choppy feel that we had before. We're still going way too fast. Let's go ahead and just edit this speed. So instead of a 3, let's bring that down to a 1. And instead of a 10, let's bring that down to a 6. That's more like it. And then go fast. So I have an issue here. You can see that when I start to snap, I do that kind of weird stop. See that one frame where it's like popping out? I'm not sure what that is, but it might be because I am doing so many different animations, but it's obviously bad. I don't want that. I'll have to think about how not to do that. Let's go ahead and make that energy burn rate a little slower. So let's add in the energy burn rate as a thing that we can change. All right, so this is much better than last week, where I spent the entire time trying to figure out whether it was a Unity or a Blender bug that was causing my animations to fuck up, and the answer was both. So the other thing I can do is I can change the color of the energy bar, and that's what we're going to do so that it becomes real obvious when you're running out. If we go over into the Diver Tentacles here and we select the shader, you can see the color in question would be the glow color, which was underscore glow color. So we're going to go ahead and override the glow color with colors of our choice. And we're just going to go ahead and make 4 colors. Just force it. And we're going to go ahead and prefab it with 3 different colors, yellow and red. We can tweak those. There's no big deal with that. And all we really need to do is... I don't know why that's... Oh, it's the actual color. It's not telling me it's an error. It's telling me that it's red. Okay, that's cool. All right, so now what we can do is we can override the color with the same basic idea here. So if energy is greater than or equal to 1, then we want to use the full. So mpb.setColor. What was it? Glow color? Glow color. And then we'll say else if energy is greater than 0.8f. Is it 2 separates? It's 2 separate. That's fine. It's going to be energy good color. Else if energy is greater than 0.2f. Energy meh color. And lastly, we could also blur between these. I don't know which way we're going to do it. We'll have to try it both ways and see which way looks better. So the basic idea here is that it will change colors as your energy goes down. The problem is that I don't know whether snapping to the new color is the right choice. It might be better if we were to... I think that's probably okay. I think it's I think the snapping gives it a properly robotic feel. I think if we blurred between them, it would be a little too organic. I like the pop, pop, pop. So we'll leave it like that, but we're going to adjust what colors we are using here. So if we take a look at our player, we can just change these colors. And I think that this blue is a little bit too bright. Let's go ahead and just soften it so that it's not the same color as when you're full. Just so that you know that you're not full yet. Okay, so there's a couple of things that I still want to do. The cutoff when you're running out of energy is really aggressive. I think that what we want to do is... Do we want some kind of dregs where it blurs? Yeah, so here... let's give ourselves a little bit. If we have some energy, but we're running really low, let's cut back. Let's go ahead and slow way down. So sprint times equals 10 times optional spirit handler energy. That'll give us, since it's between 0 and 0.1, that'll give us a scale down that falls off rapidly. But we're still going to burn. So you lose speed, you lose energy at the full speed, even though the actual quality of the sprint decays rather rapidly. And I might change that to maybe 0.2 if it doesn't look good. You still got that pop. You see that pop? There's definitely like a transition. And I don't know why that is. There shouldn't be a heavy transition right there. You see that popping? So part of that popping is because I'm allowing you to continue sprinting before your energy's recovered. So what we're going to do is over here in the diver status handler, we're going to have a burn. And then here, we're going to make this an underscore energy. If burned, there we go. That way, when we change the energy, if we burn out, then we won't have to worry about it. But down here, what we're going to do is this is going to be energy-based, but this is going to be energy-based. If we're burned out, and our energy is greater than 0.8F, I guess, we'll unburn out. And lastly, if our energy is false, my bad. And lastly, if our energy is dropped too low, we'll burn ourselves out. So there we go. Notice that we don't actually prevent ourselves from burning energy when we're burned out. The only thing we do is prevent the player from holding shift when we're burned out. All right, so I think I know what the issue is. I think I know what's causing that snap. Over here in the player controller, I multiply these values together, right? And the result here is, here it is. The result here is that when you just start holding shift, what happens is you're actually going slower and it's giving you this pop, right? So if the sprint is greater than 0, we actually want to make it so that the sprint becomes... we want to reframe it. So sprint divided by equals 2, sprint plus equals 0.5f, sprint now between 0.5 and 1. Another way to do that would be to lerp it, but this works just as well. So basically what we're doing is we're making it so that the sprint will never make you go slower than your default speed. And that should avoid that popping from whenever we were hitting shift. It should transition into a sprint nice and easy now. So yeah, that's better. So there's still plenty of things left for us to do. Adding bubbles and stuff. Okay, did you see that weird... We had a thing where it regenerated like super fast. It shouldn't have been the case. So we've burned out, and we should see it come back up as red, but instead it doesn't come back up as anything. And I think that's because I screwed something up. That's usually the case. Ah, there it is. Also, our energy recharge rate is really high. Bye, Alan. I think he probably already left before I noticed. I'm not very good at reading chats. So I think we're going to switch from a pure Boolean up-down to a float. We don't even need this. Just delete it. Boom. It's gone. What we're going to do instead is we are going to set it up based on the forwardness. So float x wobble equals dc.forward. So the y wobble is going to be dc.forward minus 0.5 f times 2. So basically, we're going to be mapping it so that at 0.5, y wobble is 0. And as it goes up, at 1, it becomes 1. Seems easy enough, right? We say, just clamp that. mathf.clamp01, that. And so then we go down here and we say this is going to be y wobble. And then this is going to be 1 minus y wobble. There we are. That should give us like a 45-degree wobble when we're sort of sprinting, when we're transitioning into sprinting. That should cut down on some of the chop we were getting, make it look a little bit more fluid. So this is us at 0.5. And you can see that as we transition towards our maximum, we don't have that sudden blast that we had before where it just suddenly snaps. And now here you can see that as we recharge, it stays red. And then, of course, we can pop back in. So there is definitely going to be, a couple of things that we might want to change. I'm not sure, though. I'll have to think about it. Either way, one of the things that we're doing here is we've got this current. And the idea is that we can't swim against this current. It's just too strong. It'll keep pushing us back. I don't know whether that works anymore. I think I might have broken it. Sure, it looks like I broke it. I'm not getting any sliding backwards at all. And there's some weird stuff going on. Looks like I broke it at some point, so we're going to go ahead and leave that. But the idea here is that you'll be able to sprint into the currents, but you obviously can only sprint for so long. That's kind of the point. Anyway, that was fun. I didn't expect to actually get it done this fast. I was so used to just sucking for so much of the time that we've had that not sucking is such a strange sensation. Actually getting stuff done doesn't feel real. Should I increase the speed of our sprint a little bit more? It feels just a little bit anemic. Let's go ahead and just bring it up from 6 to 8. But the problem is that'll change our 0.5 a little bit. We should probably just put a point at 0.5 and call it 0.5, like that is. This is our actual speed. We'll call it 2.5. So this is our default speed that we move at when we're not in a hurry. Just slow enough to be a little bit annoying. And when we want to be in a hurry, we really haul ass. Yeah, that feels pretty good. Right now I'm just kind of playing around with how it feels to see whether or not it feels right. It feels a little strange because you're not doing any of the work. It's all the tentacles. But I didn't want to add any leg kick animations without really knowing, because they're actually quite difficult to put in correctly. And I was like, if it's not going to look good, I don't want to spend time polishing something that's going to suck forever. But fortunately for us, it looks like it's going to work out fine. So I'll probably add in some leg animations, at least to the sprint. Now we have to check on our... So it's true that the tilt is backwards. It's no big deal. We can just reverse it. So let's go in and flip our tilt. Yeah, I finally turned off the Caribbean dance music. I can hear myself think again. Wah. So one of the issues is that we do not have any colliders yet. They're all on the other player. We also don't have a head camera or a light. All of those things are bound to bones. But I'm not sure that I want to keep binding them to bones. I think maybe I want to change that into... Well, no, maybe I'll just keep binding them to bones manually. Let's go ahead and just bind them to the bones manually. So basically, I can open this diver animations here, and open this diver animations here, and just transfer them across. Nothing on the arms? For some reason, I thought there was... Maybe I disabled it before. So here you can see the spotlight. We'll go ahead and grab the spotlight and the interaction caster, copy it, come down here into the head and paste it in. Is that in the head or is it outside the head? There it is. And you can see that it's not in quite the right spot, but that's pretty easy to fix. All we really have to do is drag those forward until they are pointed out the front of our face. We also have some additional elements like these silters and these hand projectors. I'm not sure about these hand projectors. The reason they're bound to the chest is so that when you move your chest, when you tilt backwards or forwards, it comes with you. And I think that's probably still good. We got some colliders built into the chest as well. I guess we'll just copy all of these. They're really primitive, though. I wonder whether I should reprogram this. For now, let's go ahead and just leave those. I am worried at what we're doing with our... here's the look at IK. So if we grab this look at IK, it's on the actual head itself. But it doesn't have to be. See how it has the head transform as a target? So in theory, I could put the look at IK anywhere I want, including right here. So if I were to have that look at IK, here's the... Is it the interaction caster that we are looking at? I think it is. But then the head can just be this here, like so. We can also give it the eyes. I'm not 100% sure about these, but what the heck, we'll try it anyway. So here's IL. IR. I'm not sure what the end is. We'll have to think about that. This might not be the eyes. This might be like the eyelids. I'm not sure. So that's not the right thing. The interaction caster isn't what I was looking for. The thing I'm looking for is actually on the camera. So there it is. Oh. The interaction caster is what we use to determine whether or not you can touch a mission target, which is something I'll just completely replace. All of the IK stuff is currently boned. But you're not looking. So for some reason, the IK target thing doesn't seem to actually be looking anywhere. If we look at where the look target currently is in the game world, where are we? Here's the look target. The look target is... That's a slosh gimbal. Where's the look target? The look target is over there, to the right, because our camera's looking that direction. So our character should be looking that direction. I can't tell if our character isn't looking in that direction or just isn't trying very hard. Well, the eyes are doing something. think there's something wrong with the eyes. Let's go ahead and turn off lighting. Yes, that's definitely much better. So I think that it might be trying to look, but there's something wrong with how I set up the rigging. I haven't fixed any of the rigging yet, so it might be just doing something silly. Let's go ahead and, yeah, so see how it says that it's looking at those? It thinks that it's looking over there. It's not. But if we take a look, we can see that the head weight is only 0.5. If we increase the head weight to 1, yeah, so you can see what happens is we end up with a snap where it's not trying to tilt our face to look at the destination point. It's trying to tilt the bone to look at the destination point. Don't think that's what we want. Okay, so I think that the way to fix that is probably to edit the actual mesh and change that bone to being in a different orientation. Let's find out. So if we take a look at the bones that we've got here, this is the head bone in question. If we take a look at how it looks in this mode, sorry, I got too used to other operations and now it's, let's go over here, layout. Fuck you. Come on, give me a, I can't figure out how to move shit. There we are. So this is the bone in question right now. You see it's perfectly vertical. And really the problem here is simply that it is perfectly vertical. What we actually need to be is perfectly horizontal because it's trying to orient this axis with our target, and that axis is not the right axis. So we're going to disconnect it from the scale head bone. Then we're going to rotate it 90 degrees on the x-axis and then move it. Like that. Now if we enter into pose mode, the question is whether or not this is actually going to look in any sort of direction that we want it to look. That's not too shabby. At least it's not distorting. So we're going to save that, and then we're going to go ahead and change this from swim fast to idle, just so that it has a little bit less of a silly bit. Since that's the default visual we'll see in Unity. Then we'll switch over to this, save it as that, unselect these as always, hit export. Wait a couple of seconds, sip some water. Go back over into Unity. Up the head weight. Hit play and see whether it worked. Oh, look, it is looking in the right direction, but it's broken. So it looks like the neck is popping off. Look at that. That's so weird. Okay, so it didn't change anything. See? It's still pointing the top of the head in that direction. I mean, I could just do this manually, I guess. It's not that big a deal. Just undo all those changes we just did. I think I can just keep going. Now, the reason I kept undoing is because I know that this axis along the bone is the y-axis. And I actually need to orient it along the z-axis or the x-axis. But the problem is that this isn't letting me change the orientation of the bone. Yeah, it's trying to look with the top of our head. That's really not what we want. Let me see. Is it just that the X and the Y are the wrong way around? The X and the Z. So if I rotate along the Z axis, that's the Z axis, huh? And that's X. What's going on? This bone is rotating around its parent? This is really weird. Maybe that's the issue. Maybe there's something much weirder going on than I thought. Okay, so if we rotate along the Z axis, I guess this is the Z axis? I didn't think it was. So right now it's oriented so that the local Y axis is that way. But here's the thing. If I were to edit this bone on a different orientation, the local Y-axis would still be the same. So let's go ahead and exit into pose mode. Rotate YY. You see, that's Y. So it was a big fat lie in the edit mode, because the edit mode bone orientation is not the same axes. This is along the X-axis, the local X. So that means that Z is actually straight out of the front of the head, which means that if we were to look with Z, it should look like this. But instead, it looks like this. Maybe I'll just manually create one. It's not that hard to do. It's just kind of stupid that I need to. All right, we'll go ahead and create our own look at IK. So down here in our scripts, divers, head handler, (15 to 20 minutes later). So we'll remove this IK look at thing. It's busted. It's not busted, it's just that it's not compatible with how I'm doing things, I guess. Find the one pixel where you can actually add a new module. Here's our head handler, pop that open. Public transform head, neck, eye left, eye right. Easy enough, right? So the idea here is that when we look at the targets, we're going to need a target as well. So the idea here is that we can point our head at the target. And we're going to want to do that in late update, because otherwise it's going to get overridden by the animator. And we don't want it to be overridden by the animator. So what we're going to do is we're going to say head.look at. But the thing is, I think look at is broken. I think it's been broken pretty much forever. We'll see whether or not it works. What was that? I don't know what that was. Just Unity being glitchy. No, it's not working. I think that's because look at is busted. I don't think I've ever managed to get look at to work. So instead, we're going to go ahead and give it another chance with set look rotation. Set look rotation allows us to point ourselves in our direction. So we're going to say look target dot position minus head dot position, like that. And then we give it a vector3 dot up of our choice. And what might be the problem is that it might be sending us a vector3 dot up that is relative to the world, and that might be why our head was doing that weird skewing. but I didn't have any option to change. Oh, you know why it didn't work? Because I didn't set up the head or the look animation or any of that shit. Let's try that again. Here's our look target. Here's our head. Here's our neck. Here's our eye left. Here's our eye right. I think that these are not the right, but that one's okay, I guess. The eyes are going to have different priorities, I think. We'll find out soon. So this didn't do jack shit. Maybe it was the look target that doesn't work. I mean the set look rotation. I can never remember which of these works and which of these doesn't. Let's go ahead and head.look at look target dot position. So it can just take a target. So we'll just go ahead and do that. Tell it to look at the look target. Brilliant, if it works. Okay, so here you can see that we've got the look target working absolutely fine, except for one teeny tiny little detail, and that is that our neck is broken. But this is not the same category of neck broken that we were looking at before. Previously, we had this issue where the top of our head was orienting towards our look target. And now you can see that it's the face. That part's right. But the problem is that the up axis is wrong. So we just pass it a different up axis. And we're just going to pass it the head's own up axis. There you go. So now what we've got is the head looking in the correct direction without being completely broken. Now we do have some issues with this. The neck is strangely long, and I think that might just be how the bone is mounted inside of the skull. But those are issues that we can fix at our leisure. Here you can see this is me looking behind, and the problem here is, of course, that the rest of the body doesn't really know what is going on. So that's why, generally speaking, you use a combination of factors. You don't just use the head bone. So in order to make that work, I guess the first thing to do is to set in a weighting on the head itself. So and the problem here is that head.lookAt creates an exact rotation. We're going to have to create our own rotation to do a lerping. So here we can specify a look rotation of our choice, and that's going to be look target.position minus head.position, head.up. And then what we'll do is we'll go ahead and start by setting head.rotation equal to Q, just to see whether or not that actually works. If it doesn't work, then we'll have to do something else. But I think this will work. Let's find out. They turned on their Caribbean dance music again. Yeah, it works fine. So now all we have to do is lerp between the current head position and this new head position. Normally I would hesitate to do that because I would just be lerping towards 100% looking, but the current head position is reset by the animation controller every frame. So head.rotation equals quaternion.lerp, and then we're going to lerp between head.rotation, Q, and we're going to do our head weight, like that. So if we bring the head weight down to 0.13, okay, so that is actually not So a couple of problems. First off, the lerping is not resetting, which means that the animator probably isn't actually animating the head in the way I thought it was. Second off, when I look to the left, you can see that we're actually snapping our necks. So what we're going to have to do is make our up axis not head.up, but our actual local up. So that's not a big deal. This, however, isn't working. So just replace that with this for the moment. It looks like the animator might not be resetting our head. There needs to be a couple of ways to check. We'll go ahead and try a couple of things. So here you can see we are looking and we are using the wrong axis because we don't want to use our up, we want to use our forward. Because our forward is straight along the axis of the body, but it won't change as the player's head moves around. So straight along the axis of the body will always be our up, or our forward rather. So that's going to always be a good thing for us to use. So here you can see we're no longer getting that neck snap. If we look over here, no neck snapping. Nobody's doing any neck snapping. Everybody's happy. Hooray. Everything's working. But we do have an issue because we can't change the weighting in this manner. So if we take a look at this, we're off to the side here. It looks like we're drifting forward. I know why that is. I'll fix it in a second. But the other thing we're going to do is turn off the head handler. And you can see that although we turned off the head handler, the head remains tilted, which implies that the head's not part of the animation system. I'm not sure why that would be. I don't think I turned it off. Interesting. Well, either way, that means that we're going to have a hard time getting this to do the element we need. So I guess what we'll do is the look target's weight. We're going to go ahead and lerp between two different look rotations. So we're going to do Q0 and Q1. This one is going to be transform dot down. I can't do down. I can do negative transform dot up though. So basically, we're going to have a different. Yeah, that should be fine. Aubrey Beardley is telling us that he's doing a lewd game. Well, sounds fun. I am fixing up my game to be more tentacle-filled, but it's not the same kind of tentacle, I'm afraid. Woohoo! So here what we've got is, yeah, that's definitely less aggressive. I think that's going to work. So I could make it so that the eyes were involved, but there's not really a big need for that because we can't ever see our own eyes. The thing I do want to do is make it so the neck is involved, but I'm just not sure how that's going to end up looking. Let's fix our forward drift first. And the reason we've got forward drift is because this isn't where it should be. This should be at 0. There we are. And Aubrey says that he's not actually making a game about that today. He's just doing art about that. Well, it's fine too. I'm sure that both of them are fun. But I need to figure this out. I think that if I change the... Come on, just give me this line. Let me thank you. Neck weight. I think that if I set the neck weight before I set the head weight, it'll be a little bit better. The problem is I don't actually know. Well, let's try it. Let's go ahead and just set the neck to looking at the target. I have a headache all of a sudden, so I might not stick around too much longer. It's already been like an hour and a half, which is long for me. So let's go ahead and... There we go. Let's see whether that made any sort of difference. The problem is that the neck might be seriously broken now. Yeah, you can see how the neck is seriously broken. And that's because the neck is not on the same axis as the rest of the character's body. So if we take a closer look, you can see how the neck is definitely... ripping. What we want the neck to do is to bend in a direction so that we can easily see our head bob up and down properly rather than just kind of skewing around. But the problem is that the neck axis is not the way it should be. It looks like it's 100% backwards. And if that's the case, that's not too difficult to do. All we really have to do is reverse all of these values. We'll go ahead and give it a shot and see if it's 100% backwards. And if it is, hey, problem solved. It was just 100% backwards. All right, so now what we've got is a neck that should help our head bob correctly. But basically, we don't want the neck to be as strong as the head. So if we increase the head weight and leave the neck weight, we can do it this way, or we can do it the other way around. We can reduce the neck weight. It's not going to drive our head any closer to the target look destination because we're using global orientation for our head and our neck for that matter. So that means that it doesn't care what the local animation, the local orientation is. The head is mounted to the neck, but rotating the neck and then rotating the head means that the head's value does not depend on the neck because we're setting the head's world coordinate rotation. If we did it the other way around, then the head would rotate further once the neck rotation was set. But since we're doing the neck first and the head second, we're avoiding all of those problems. I think it's time for us to take a quick little demo, screenshot. GIF, but I think I'll do it off screen. The only thing I want to do on screen here is just drop some other material onto these boots because they look crappy. I mean, I know they're just test boots, but I don't want the test boots to dominate people's opinion of what the heck's going on. So we're going to drop in diver gear right there. Since the diver gear has the ability to do that, let's test and see whether it can. If we drop in the player here, we can see that there is an option to add in more diver status handler materials. So we're going to go ahead and drop the crap fins into that list. And hopefully that'll mean that they react properly when I use up energy. They do. Look at that. They overlap with each other, so it looks weird, but they work. I might have to think about my animations because if I'm going to have a highlight there, then it's going to be really hard to see when they overlap. All right. Thanks for hanging about. I will see all you folks on, well, I don't even know. Is Wednesday Christmas? If it's Christmas, I probably won't see you. I can't remember what day these non-secular holidays are. So see you around. Maybe next year, maybe earlier. Whenever I happen to see you, I'm sure it's fine. Have a good one, and thanks for sticking by.